Hello everyone, my name is Afrin Maliat, and today, together with my groupmate Nimesh, we are going to present our topic on vehicle to grid and grid to vehicle operation of a bidirectional battery charger for electric vehicles using MATLAB. This is the outline of our presentation, which includes the introduction, power grid structure overview, the structure of bidirectional charger, how the multifunctional battery charger is managed, then the grid voltage and current while using the V2G, the modeling and simulation of our project, results and discussion and conclusion are also included.
The most pressing challenges confronting humanity today include growing greenhouse gas emissions, pollution of the environment, and worries over finite non-renewable resources such as fossil fuels. To address these issues, development is being made a variety of sectors, including transportation and renewable energy sources. Since the inventions of the first autos, the notation of electrifying transportation has been voyage. However, as the effects of previously described difficulties grow, electrification of the car becomes important and is currently the subject of intensive study and commercialization. With advancement in power electronics, these advantages of EV vehicles go beyond reducing emissions and place great force on renewable energy sources. A number of studies have been indicated that widespread usage of grid-connected cars, which including EVs, PHV, plug-in hybrids, and fuel cell vehicles enhance the electrical grid. The grid-connected automobile batteries can act as an energy storage system for the source of renewable energy used to generate power today. Automobiles may also assist manage the voltage and frequency of the grid and deliver energy when needed, especially during the peak hours. However, in order for these capabilities to be put in action, car must establish two-way link with grid. This will enable them to charge the battery as well as pump electricity back to the power system. As a result, bidirectional chargers were the topic for several scientific investigations, and the present research effort is centered on determining the ideal charge configuration that can permit bidirectional power transfer between the car and the grid. A number of operating modes were developed as a result of the power flow, including G2V, grid to vehicle, which allows battery charging directly from grid, and V2G, which is vehicle to grid, which permits battery discharge to the grid, and finally the ability for the vehicle to operate while the grid is supplying electricity to the home. Because the bidirectional charger is not actively charging in this mode, it's uncertainly if it is can function as an active shunt power filter, whereas the battery powers the home. Using the charger for several users has an obvious economical advantage since it eliminates the need for an extra external active filters. In next slides, the bidirectional charger structure will covered. After that, the control of each of the operating modes, uh, as well as the control algorithms determines which mode of operation is utilized to be covered by modeling the system with MATLAB-SIMULINK. In this slide shows the figure which the power grid structure overview. The majority of electric vehicles, electric bicycles, electric motorbicycles, chargers are situated in cities where the medium voltage transmission grid is typically 15 kilovolts. In the figure, the grid with the medium voltage at 15 kilovolts, it fuels the DC bus through bidirectional AC to DC converter. The PV panel and wind turbine both supply the same DC bus of 653.2 volts and 26.7 kilowatts DC load, and the 40 kilowatts of both chargers for EV charging and discharging are provided by the DC bus in turn. The DC load represents the additional DC loads such as electric bicycles and electric motor bicycles. The most popular and commercially available off-board charger is for 40 kilowatt, and the ampere range is 100 amperes. The levels established by the Society of Automotive Engineers all place the stated off-grid chargers above level 2, which is the lowest level since they can fast charge. They are classified as level 3 vehicle supply equipment. In the figure shows considered in this work, but the PV panel and the wind turbines are not included. As a result, the study will concentrate on how the grid responds to the power flow from the EV without the help of PV panels and wind turbines.
So the charger for our presentation is built from a three-phase bidirectional AC to DC converter as well as an independent bidirectional DC to DC converter. As a result, the charger shown in this figure can be utilized with stage 2 or stage 3 charging. It can also be mounted within the car for relatively low charging power levels or outside the vehicle in a separate charging station for higher power levels. So we have utilized a LCL filter here to decrease the grid current ripple in order to ensure that there is minimum total harmonic distortion now at the grid side. While guaranteeing the stability of the entire system, the values of the filter must be selected accordingly. And a three-phase VSI, which is voltage source inverter, AC to DC converter, is also utilized in this application by altering the kind of switches used. This bidirectional converter, which allows electricity to flow both from and to the car battery, may be made to accommodate a variety of charging power levels. It is connected to a dual active bridge DC to DC converter. The isolation provided by the transformer between the battery and the grid is one of the most crucial aspects of this design, and it is crucial for a number of reasons, including safety. The dual active bridge can guarantee appropriate V2G and G2V operation of the car because it is a bidirectional converter. This entire structure or the architecture of the charger is especially important in this application, since one of the key aims is to develop this charger was to provide acceptable range or power reliability across the different operation conditions. So now I'm going to talk about the management of the multifunctional battery charger. So as part of the G2V operation, the grid should charge the car battery in line with the charging power levels of our desired structure. The batteries in this study are charged using constant current called constant voltage charging method. During the first charging stage, the current reference is adjusted to an acceptable charging power level. The voltage of the battery increases as it is charged at a constant current until it gets to the highest voltage permitted by the manufacturer of the battery. The battery then begins the succeeding charging phase, where during the voltage is increased to its maximum value and the current gradually drops until it reaches the battery's cutoff current, which is the state of charge, with the battery's state of charge reaching its maximum value. Since the charger is completely bidirectional, when appropriate and under the correct situations or circumstances, the battery may pump power into the grid. The AC or DC control does not change whether the charger is working in G2V or V2G mode, since the DC link voltage must be kept constant. Here our DC link voltage is 700 volts. The DC to DC control, however, changes, and because the battery which is used as a source in the V2G mode can only inject a particular or certain amount of power, it was decided to use battery capacity as the benchmark for this operation mode. This regulation allows for a power factor of 1 at the alternating current mains.
In this slide shows the grid voltage and current while the V2G conversion as a flowchart. According to the illustration, the DC link capacitor must first be full charge and the DC link voltage must be less than 700 volts in order to charger to function. The next action is to examine the state of the charge of the battery. The charger may function as an active filter if the battery's SOC is greater than 80% while it's not being charged. The battery SOC should constantly watch then in the active filtering mode to make sure that it does not drop below 70%. If this occurs, the battery must start charge and the active filtering must be turned off. In this slide shows the modeling and the simulation results of the project. First of all, the MATLAB is used to test the charging and draining of the battery, and the results are shown in next slide. The charge process or G2V capability is first tested. As you can see in the figures, despite the grid current and the voltage which are in a phase as a consequence of AC to DC converter's power factor correction control. CZ to CV charging does not appear in the grid current and the voltage because of the combination of powerful that separate the battery charging operation from the grid waveform. The figures depict the voltage and the current from the grid. Current and the voltage are in phase when the G2V mode is activated. In V2G, they are likewise 180 degrees out of the phase. There is no need for grid electricity when a small number of V2G electric vehicles can fulfill the demand of G2V electric vehicles and the DC load. Because there is no electricity from the grid in this instance, new modes of operation such as vehicle to vehicle or vehicle to load are formed. The charger may also check to see if the grid current is almost sinusoidal and if it is adheres to the IEEE 519 rules, which specify the maximum permitted fraction of each current harmonic. The research of this study shows the charger design control capability satisfactorily in the two working modes, which is G2V and V2G, for which they were made. Two unexpected results that are not explicit reveals in the constraint but rather might be resonant from the two figures are the battery appropriate charge and adherence to the greatest allowable battery voltage. It is critical to take note that the metric voltage and current are unaffected by the progress from consistent current to steady voltage mode, and that the transient impact are reduced, however not apparent. The dynamic isolating action of the bidirectional charger is made and controlled to work for higher charging power, as would be viewed as ordinary to be unsurprising all through the battery charging time. An adjustment of power reference impact the battery presentation and abbreviative its life. Voltage unbalance are not concentrated on in this review, particularly compared to the dynamic shifting activity, yet they would be reviewed as raising the dynamic channel while rating, while at the same time keeping a similar level of control. This study presents the design analysis and modeling of bidirectional EV charger composed of DC to DC converter and AC to DC converter. When when connected to the home, this charger may charge batteries G2V operation and discharge batteries to grid V2G operation. The objective is to achieve the top limit of the criteria for power quality and suitable battery charging and discharging. The statistic provided in tow mode of operation shows that the charger's control can fulfill all requirements and create the groundwork for the experimental setup that will be the subject for later research.
Thank you everyone for listening to our presentation. I hope you liked it. Thank you.